Hi everyone, I hope you are well. Today I'm going to introduce my team. They are Juliana Zapata, Tomás Patiño, and my name is Juan Pulgarin. In this case, I'm going to introduce our topic. Our topic is Petri needs applied impulse algorithm analysis for a rocket engine test with liquid propellant. So my class may continue with the explain of this topic.
Okay, first, the name journal is Petrinet's Applied Import Algorithm Analysis for a Rocket Engine Test with Liquid Propellant. The journal publication date was 24 February 2023, and this journal is in the second quarter. The authors are Eduardo Rostirola Bortolotto, Francisco Carlos Parquet Bizarria, and Jose Walter Parquet Bizarria. And the link of the journal is this. Okay. Our article is about using Petri nets to simulate a liquid rocket engine test bench. Before flying, each rocket engine must be tested safely on the ground. These tests are complex and expensive, like valves, sensors, and computers. So engineers use the computer simulations to check how the system works before building it. Okay, for the Petri nets, a Petri net is a graphical tool that shows how a systems work and the events, timing, and connections between parts. In this project, it was used to simulate the fuel input process, which cleans the pips before and after rocket tests. For the state of the art, in this case, when the Petri net is really it's simulated on computer to see how each part of the system reacts over time. The simulation helps check the timing, synchronization, and use of resources like fuel and sensors. Okay, finally, this rocket engine test bench. By simulating everything before, engineers can make sure the test is safe, efficient, and well coordinated. In summary, this article shows how Petri nets can help the test improve rocket engines, making the development process and cheaper, faster, and safer. Okay, next.
So, the authors propose a Petri-net model to simulate and understand the pure system. So, the system has three levels: actors and sensors with the physical parts control where commands are processed, and HMI, the human machine interface for human interaction. The diagram below shows shows how all components are connected. And on the right, we see the automatization layers built with Petri nets. So the first layer model that has actor and sensors. The second represents control logic, and the third shows the HMI actions. Together, these layers form a complete model of the work process in the rocket test bench. Next, please. So we can see the complete Petri net model for the pure system. It is divided into the same three sections: HMI, control, and actuator sensor. This big model shows all the connection events and transitions that happen during the process. With this model, the authors could simulate how the system works for building it in real life. This helps to find problems, understand how components interact, and make sure the process is safe and efficient. So this diagram represents the full operation of the pure system through Petri nets. Next, please. And we can see the resources used for the simulation. Petri nets give a graphical and a mathematical framework to describe and analyze systems. With computational resources, simulation can test different situations and verify the system behavior. The right image shows how the simulation helps in synchronized and efficient development of rocket propulsion system. In conclusion, this part of the article shows how Petri nets and computer simulation can model and test complex systems like the pure system in a safe and effective way. Next.
So continuing with the development, as we can see here, we have a chart. This flow chart, which was essential for the development of PetriNet. And finally, as we can see here in right, the right, we have this sketch. This sketch um, uh, when all the conditions of PetriNet are met, puts valves open and activating the system in a safe manner. So next, please. Main contributions or observations is the system operates continuously without crashing, and the number of tokens constant indicating stability. Standby mode. All parts of the system can be activated correctly when needed. Responsives on were detected, which were correct by adjust the model. And so, in conclusion, I think that Petri needs helps engineers to study and improve rocket system. They are clear, cheap, and useful for space automation work. And that is all. Thank you for the paying attention.